Hello, in this video we're going to show you how to perform a standard target field calibration of an HTI Model 241 echo sounder using a split beam transducer in the water and a standard target sphere. The purpose of performing a calibration test is to measure your transducer sensitivity, your system gain, and frequency response of bandpass filters in an environment that is similar or the same as your field study. To perform the study, we want to utilize a homogeneous sphere target, which will have the best acoustic resonant properties. And the best metal to use is tungsten carbide. This resonates at higher frequencies than most metals, does not corrode, and it has superior acoustic properties. We want our sphere to be suspended in the water using an acoustically invisible material. We've tied a net around our sphere using this monofilament fishing line. There are instructions provided separately as to how to perform this tie. The size of our sphere is selected based on the frequency of our echo sounder. We're using a 200 kilohertz echo sounder, so we're using a 38.1 millimeter sphere, which is appropriate for kilohertz ratings from 38 to 200. So as we begin our study, the first step we want to do is spray down our sphere with a little bit of a solution of dishwashing soap and water. This will remove grease and air bubbles on the sphere, which could be acoustically visible in our test. I'm going to go ahead and lower the sphere into the water. It is important to perform this study in an environment away from currents, fish, debris, and other objects that could interfere with your readings. The idea is you want to isolate the sphere alone in the DEP software so you get a nice clear reading of your sphere. We have already positioned our sphere just with the line here taped to the barge deck at the correct depth beyond the near field range of our transducer, usually about 3 to 5 meters, and also in the correct horizontal plane, up, down, left, right. This can be a little tricky to do, and you want to spend time and care to get this done. As you can see in DEP software right now, if I move my target around side to side or up and down, you'll see movement in your 2D plot and in your echogram. And now we should be back, since it's stabilized, back in roughly the center of our 2D plot. It's not absolutely imperative that you get your target right on the center, but you want to be as close to it as possible. That's going to give you the most clear readings. So now that we have this placed, we're ready to power up and go collect some data in our software. So now that our target sphere is suspended underwater within the beam of our transducer, we want to use our digital echo processing software to collect about 500 to 1,000 echoes from the sphere, and we will measure the amplitude and range of the echoes, range being distance from target, to estimate our transmit-receive sensitivity of the transducer. Our echo sounder here, you can see, is flipped to enable because the transducer is underwater and we are receiving data from the transducer. In our DEP software, before doing this, which I've already done, but the first step is to open our configuration file. Ours is right here, it's already open. The configuration file will determine the settings for your study and for your calibration test. You want these to be the same as whatever is optimal in your environment to track fish for your study. We have it set proper for where we are located. I've already connected to the network, so I will go ahead and start to process data. And you can see in our 2D plot, we have our target is somewhat visible here. It's kind of getting a lot of scatter. And there's a reason for that. The reason is over here in this window, our echogram. As I showed before with the target moving up and down, and you saw this line move up and down, well, this line here is our target. The reason we're getting scatter over here in our 2D plot is because currently you can see the hard bottom. Hard bottom is the ground, the surface underwater, the muck that's down there. This line here is that. This third line is our bottom setting. So to get rid of the hard bottom surface floor of the water, we want to filter that out. So what we do is we've set our bottom tracking here to manual. You can see right now the bottom is at about 9.2 meters, 9.1 meters. That's where this line is in the water column. So I'll use this bottom control knob that's hooked into our echo sounder right here to raise that bottom. And you can see as I turn the knob, I go down, I'm turning it to the left, and I brought the bottom right here up above the actual bottom floor of the water. And now in our 2D plot, you can see we've isolated only our target, which is suspended at about 5.8 meters underwater, that number being right here. And when I put my mouse over the target, I see 5.8 meters. Our bottom, if I put my mouse there, I see 7.4 meters. 7.3, 7.4. Down here, where it says echoes, this is the count of how many echoes I've collected. For the purpose of this study, we only need to collect about 500 to 1,000 echoes so that we can run good statistics on those echoes. Right now, I've already collected over 2,000 echoes just in the time that it took to demonstrate setting the bottom and filtering the bottom to isolate our target. After we've collected enough echoes, we can go back to command, stop processing, and when I do that, the software saves a .raw, a raw data file, which when we go back to the office, we can open up in Echoscape and run some statistics on our data and determine the transmit-receive sensitivity of the transducer. It is important to notice that your file name that's going to be saved is located right here. You may want to write that down before moving on. And right here in sampling plan output files, right here you can determine the location of where your raw files are saved. So that concludes our work at the barge in the field using our DEP software. And when we get back to the office, I will show you how to run statistics on the data we collected to estimate our transmit-receive sensitivity of the transducer.
Now that we are back in the office, we want to show you how to use our Echoscape software to run statistics on the data that you recorded in the field during your sphere calibration test, and to make sure that you're getting an accurate reading of target strength, that you have enough echoes to validate the statistics, and that your standard deviation is nice and low. To get this started, we already have Echoscape open on our computer, so we will go to File, New, and locate on our hard drive where our raw file is that we created in the field. We want to single click this file so the file name populates the field right here, and then come down here and click Copy DEP Name. And what this does is copy the file name into our new database name field. If you'd like, you could go ahead and type any custom name for your new database here as well. After that, click Directory Selection and locate the location on your hard drive where you want to store your new database. Once you've done these things, go ahead and click Create, and we see our data that we collect in the field right here. To better view this, I'm going to go to my Tool menu, select Zoom, and just zoom in over the data that we collected. It's all this white data here. Kind of like we saw in the field, this more fuzzy bottom line here is the bottom in the water. It's not our sphere. Our sphere is this nice clean horizontal line here. And at the point at which the bottom disappears, that would be where I had filtered out the bottom in the field. So what I want to do is come to my Tool menu here, select Mark, and just draw a rectangle around my sphere data, like so. You see that turn red. Next, I'll go select a Fish Tracking menu, Store Summarized Fish, and we see my sphere data turn color once more. Then I'll go to the Search menu and click Tracked Fish. And this gives statistics on the fish, or in this case, target that we have marked in the software. Importantly, right here, we see our target strength. I'm seeing a reading of negative 38.88, which is very, very close to the projected value of negative 39. It's very, very rare that you're going to get a value that's exactly what the projected rating was, but generally within about 1 to 2 decibels is going to be acceptable. So this is very good. Right here I can see I have 1,694 total echoes, which is more than enough. We recommend at least 500. If you can do more than 1,000, that's even better. We just want a number high enough so that these statistics are valid. Right here we see our standard deviation, and mine is 0.170, which is nice and low. So that concludes our test. We've shown you how to set up a sphere calibration in the field, how to collect data for it, and how to take that data back to the office and run it through Echoscape to get your readings of target strength, number of echoes, and standard deviation.